Good morning, good afternoon, good evening. It is the Oracle of Chinemkutu and welcome back. We are here today with a very challenging question. It is a board examination question for actuarial students. And it is also a question that can be given to students of financial mathematics or mathematics of finance. Financial mathematics is the best description of it. In either first, second level, depending on the curriculum. And it is basically a question that deals with the discounted cash flows and also the future values and time value of money. So this question is interesting in that the understanding of the English and the terminology that is used is very important. You might be good in the mathematics, but if your English is challenged and you do not have a grasp and understanding of the terminology that's being used, it might be a problem. So not only do you have to understand the English and the terminology that is used, but you also should be able to visualize what the question is talking about. Because without that visualization, it might be a little bit difficult to understand what's going on. So there are two things. Let us read the question first. The question says, two bonds paying annual coupons of 5% in arrear, that is important to note, and redeemable at par, have terms to maturity of exactly 1 year and 2 years respectively. The gross redemption yield from the 1 year bond is 4.5% per annum. Another important term, the yield. What is the yield? Per annum effective, and the gross redemption yield from the 2-year bond is 5.3% per annum effective. You are informed also that the 3-year par yield is 5.6% per annum. And the questions that you should answer are: calculate all zero coupon yields and all 1 year forward rates by the yields given above. So there are two questions. One, it is to calculate all zero coupon yields. In other words, there are more than one zero coupon yields that you need to calculate. And all 1 year forward rates, there is also more than one 1 year forward rates that you need to calculate. I was given this question by an actuarial student, and we worked and discussed it, and I found it so interesting that I decided to do this video. And I've already worked this problem, and I'm going to show you the steps that you can take in an examination in order for the question not to be that challenging. It was a 12-mark question, and an understanding of what is required of you is the first step. So I will use my scripts, and we will solve the question as we go along. So the first thing that we have to realize is there are two bonds paying annual coupons of 5%. So we will assume a nominal of 100. That means our bond's face value is 100. And therefore, if our nominal is 100, the bonds are paying a coupon of 5%. So we say, therefore, the coupon equals to 5/100 times our nominal of 100. That gives us 5. So this is done just to make sure that we have got a round figure for our coupon. And with the bonds, what happens is the nominal is paid in arrear. That means if you have got a number of periods, your first payment is after the end of the first period, your second payment is at the end of the second period until you get to maturity. Maturity is at the end of all the periods, and that is when you get coupon paid as well as the value, original value or the first value of the bond is paid back to you, which is why they call it par, redeemable at par. So you get the coupon of 5 and also the nominal of 100. And the yield, what is the yield? The yield is the discount rate. That is the rate at which the accruing, or the rate at which the coupons and the end payments accrue interest. So we will be discounting from the end of the period back to the beginning so that we can get the net present value of the bond. And that is how bonds are priced. You calculate the net present value of the cash flows from period to period up until maturity, and that is what we call the conventional bond pricing method. So now, before we deal with the third part, we want to ask ourselves, what does it mean to calculate all zero coupon yields? So in other words, what they are saying is, if you are going to use the conventional bond pricing method, you use a flat rate for your yield. But when you are assuming zero coupon yields, you are saying to yourself, any cash flow that comes at the end of any particular period, you treat it as a zero coupon bond. In other words, you are saying that this cash flow, I will discount it at the spot rate. That means you are going to discount that payment according to the spot rate for that period. So if you have got 2 or 3 periods, you will be having spot rates from period 01 to 1, and then 1 to 2, and 2 to 3. Whereas when you are doing the conventional bond pricing method, you are looking at a flat rate of yield. So here we need to draw a few diagrams to illustrate what is going on here. So we have been told that we have got 2 bonds which are paying a coupon of 5% in arrear and redeemable at par, and their maturity, that is the end of the period where you get your coupon plus the par value of the bond, are exactly 1 year and 2 years. So if you look at the conventional bond pricing approach, and here we will be looking at the arbitrage free pricing using equivalence of zero coupon bonds. So the reason why they call this arbitrage free, that means if you look at the conventional bond pricing approach, the net present value that you determine using that approach should be exactly equal to the net present value that you will get when you are using the equivalence of zero coupon bonds. If that price or that net present value is not equal, then you have an arbitrage opportunity. So that's why we say arbitrage free pricing using equivalence of zero coupon bonds. So for the two bonds that we are told here, the first one we are told it starts from 0 to period 1. We can make this short because we are going to have the second one, which will be having more than one period. So if you start from 0, it matures here, and at the point where it matures, you are paid your coupon 5 plus the 100 par value of the bond, and we are told that the yield there is 4.5%. And if you come to the arbitrage free pricing, you will have the same scenario as 0 there and the 1, and here you will have your 5 plus 100, and your spot rate would be exactly 4.5%. So note that the first scenario, the spot rate and the conventional bond pricing approach are exactly the same. So here the implied zero coupon yield is 4.5%. So we can use another color to spice things up. So here, the implied zero coupon yield for this 1 year bond is 4.5%, and you do not need to calculate this because it is obvious from the question that this remains 4.5%. So then we look at, if you can call this your bond 1, then you can come to bond 2, and there we have a bond that is 2 periods. Here is 0, here is 1, and here is 2. So in period 1, you are just paid the coupon of 5, and at the end of period 2, which is the maturity period for that bond, you are given your 5 plus 100. And here we are taking a flat yield rate of 5.3% for per annum. So that means in the first period we have got 5.3%, and in the second period we have got 5.3% effective for each period. In other words, the 5 coupon that you are paid in period 1, when you discount it to the beginning, you use the yield of 5.3% or the discounting factor of 5.3%. And then at the end, when you get your 5 plus 100, you use the 5.3% for this period as well as, and go back to 2 periods for your discounting. And that is the conventional bond pricing approach. Then when you come to the arbitrage free pricing using equivalence of 0 coupon bonds, you then say, this is your picture. This is your 0, this is your 1, and this is your 2. So at this point, your coupon of 5 is paid, and at this point where the bond matures, you get your coupon of 5 plus your par value, which is 100. And here we know that the spot rate is 4.5%, which we have been given in bond 1. So your spot rate for the beginning of the period is 4.5%. And the spot rate for period 2, we will call it Y2, and we need to calculate that. So the implied zero coupon yield for this 2-year bond Y2 is to be calculated. So you need to get Y2, and then here we will just use the this session to answer the first part of the question. I want it to be clear, so obviously we are at some point going. So we were saying for the third part, you are informed that the 3-year par yield is 5.6 per annum. This is where most of the students are floored by the English. But it is clear that you have to imagine that the bond is a 3-year bond, which is priced at its par value. In other words, that means the net present value of the cash flows from that bond using the conventional bond pricing approach is 100, which is our nominal, that is the par value. And once you have got a bond whose net present value is the same as its face value, then its yield is the same as the is the same as your discounting factor. So that means 5% here becomes the discounting factor as well as the coupon. In other words, that means that it will be paying a coupon of 5.6% in arrear rather than just 5%. So that is a very important concept, and it is something that you should be very aware, and you should realize the information and the English as soon as it is given. So they say you are informed that the 3-year par yield is 5.6% per annum. In other words, you are going to be having a bond with the following characteristics. This will be 0, this will be 1, this will be 2, and this will be 3. So here you will have your coupon of 5.6 plus 100 paid. It matures at the end of 3 years. And here you have your coupon of 5.6. Here you have your coupon of 5.6. And here, obviously, it's in arrears, so there's nothing there. Then from there, you see that your yield with the conventional method remains the same per annum from period to period. So then, if you move from that side to this point now, you will be having the following scenario. So this will be your 0, and this will be your 1, this will be your 2, and this will be your 3. So here, you will be having your coupon of 5.6 paid. Here, you will have your coupon of 5.6 paid, and here, you will have 5.6 plus your par value 100 paid. So, from the previous diagrams, we note that our spot rate for the first period is still 4.5%. And then your spot rate, our spot rate for period 2 is Y2, which we still have to find out. And once we find it out in the first scenario, we will use it in the second scenario. And then we now need to get Y3. So then we can say the implied zero coupon yield here we've got an R for this yield for this three-year is Y3 and is to be calculated. So of course in the examination you do not need to you won't be talking like I'm doing, and you just draw these diagrams to illustrate that you understand what is going on, and that is not going to take you a long period of time to do. So then we can put a demarcation between the two methods so we can see what we are doing, but we will work everything together. So here we can put a dotted line. Indicating the two separate sides. So now you realize that your first part of the question requires you to answer, to calculate y2 and to calculate y3. So here we will say to get y2. So to get y2, we use the conventional bond pricing approach to get the net present value of that bond, which is going to be the price of the bond. And then we equate it to the arbitrage free pricing using equivalent of zero coupon bonds. So then you will have a scenario like the following. For the first coupon there, you have 5 discounted back by 1.053. And then for the second period, you have 5 discounted back by 1.053 plus your par value. This should be squared because it's the second value, the second period. And here you will also have 1.053 squared. So in other words, this is your net present value calculation for bond 2, where we are using the flat yield rate of 5.3%, where we have our coupon 5.3 paid in the first period, and our coupon of 5 paid in the first period, and our coupon of 5 paid in the second period, and then we get given back our par value of the bond, which is 100. So in other words, you can actually say 105 over 1.053 squared as one thing. I have separated it so that you should be clear as to what is going on. And this here, if you call this one 1 and this one 2 and this one 3, this should be equal to this should be equal to 5 discounted by 1.045, which is the spot rate for the first period, plus 5 over 1 plus y2 squared, which is the coupon in the second period discounted back 2 periods, plus 100 over 1 plus y y2 squared. At the end of the second period, you get given back your coupon plus your par value. And the net present value by discounting should be exactly equal to the conventional bond pricing approach. Otherwise, you will have an arbitrage opportunity. And an arbitrage opportunity is whereby you have the same market offering two different prices for the same commodity. So what you will do is you go and buy at the lower price and you go and sell at the higher price. So you don't want a market that does that. So we want this to be arbitrage-free pricing. And then once you have got that, you can now solve to get the value of Y2. And this worked out to be 99.44453,914. You can use your calculators to see whether this value is correct. And this question obviously is meant for mature students, so you can verify these calculations. And here we had the 4.78 for 688,995 plus 105 over 1 plus y2 squared. So I just combined these two, common denominator 1 plus y2 bracket squared, and then 5 plus 100 gives you 105. And then you can bring this to this side, it will subtract. So you have 99.4 minus 4.7, and that will be equal to 105 over 1 plus y2 squared. So then it will be 105 over 1 plus y2 squared equals to 94.65985,014. Then from there you have the 1 plus y2 squared. Basically this comes this side and that comes this side, divides this, multiplies. So you have that equals to 105 over 94.65 98504. And then you can remove the square root. For this, you can remove the square root by taking square root on both sides. So this becomes 1 plus y squared is equal to 105 over 94.6598504 to the power half. And you can come this side and you will have y2 equals to bracket 105 over 94.6598504 all to the power half minus 1. And we get y2 equals to 0.0232024368, and that is your first solution. So we will need this solution here. So we will write it here as y2 equals to 0.0532024368. Yeah, we can leave it like that, so we can clean the board and then find out what y3 is. So now we will calculate y3. We already know what y2 is, and you can multiply by 100 to put this as a percentage, which would be 5.320. You can round it off. I prefer working with the numbers as they are until the final solution, and I will do my rounding off on the final solution. So now we do the same using this scenario here and this scenario here. And so basically from the definition that we have been given there, that you are informed that the 3-year par yield is 5.6 per annum, we already know that the net present value of this bond is actually 100, because it is a bond which is selling at its par value. So the yield and the discounting rate, the coupon rate coincide. So just for the fullness of things, we are going to say finding y3 using the conventional bond pricing approach. We will have 5.6 over 1.056 for the first coupon payment, plus 5.6 over 1.056 squared for the second coupon payment, and then we will have 105.6 over 1.056 to the power 3. And here, notice that I have added already and discounted using the yield, which is our discounting factor, and which coincides, by the way, with our coupon. So in other words, this becomes 105.6 over 1.056 raised to the power 3. And the reason why I did this is just to show you what this statement means. You can actually work it out. Otherwise, we should have just gone straight and written 100. So we can say this one is 100, and then we say this is equal to, we come here, the first period, we know that the spot rate is 4.5. That is given there. And then the second spot rate is Y2, which we have already calculated there. And we use these two to get Y3. So we are going to say 5.6 discounted back to the beginning using 1.045, our spot rate for period 1, and the 5 0.6 over 1.05322024368 squared, plus on the third period we get our coupon of 5.6 plus the 100 par value of the bond, and we discount it back 3 periods to the beginning, and this will be 105.6 over 1.0, not 1.0, because we are actually looking for Y3. So we don't know the discount spot rate there. It is actually what we are supposed to get. So we will say 1 plus Y3 all raised to the power 3. So in the exam, you don't need to do this. From the information you have been given, you already know that this is 100. So it is 100 equals to these two work out to 10.40737 442. You can use your calculators to confirm that this is indeed correct, plus 105.6 over 1 plus y3 all raised to the power 3. So the manipulation is exactly the same as in the beginning. The 10 comes that side, it is subtracted from the 100, and we have 105 over 1 plus y3 to the power 3 is equal to 89.59262558. And then we do the same thing that we did in the first solution. Obviously what it means is we have y3 equals to, this comes this side to divide, this comes this side, it multiplies, and once we are getting the ratios of these two, we look for the cube root of those ratios and subtract 1. So we will have 105 over 89.59262558, all to the power of 1 over 3 minus 1. You can see that I am skipping a lot of steps here, and the reason why I'm skipping those steps is because I'm dealing with mature students. You can follow through. The instant I have put this equation here, you are supposed to be able to follow through and get the same solution as I'm getting here. Otherwise, if it is for students at school level, we will try and follow all the steps so that they can grasp the ideas of solving equations. So then we will say y3. If you use your calculators, you will get y3 equals to 0.056324172. And your solution is done. So then we can write the yield rate for the third period, or your spot rate y3 here because we are going to use it when we answer the second part of the question. So here we have y3 equals to 0.056 324 172. And you can write this as a percentage, which would be 5.632%. For the time being, we can leave them as they are. But if you are going to give your final answer, you can round them off. But in the working of the next part of the question, we will use these numbers as they are because we do not want to have round off errors. So then the first part of the question is done. Here you have done the spot price for Y2, and you have done the spot rate for Y2, and you have done the spot rate for Y3, and you have calculated all the zero coupon yields implied by this side. So we are actually done. I will clean the whole part and then put new diagrams for the next question. We will start the same approach by discussing the diagrams and what they mean, and then we go and work the solutions to the second part of the question. So now we are going to look at the second part of the question. Of course, you cannot answer the second part of the question without knowledge of the solution to the first part. The first part of the question required you to calculate the spot rates implied by the given rates, the given yields. And now they want you to calculate 1 year forward rates implied by the same yields that you calculated these two. So we are going to put two diagrams which shows the scenario that is happening, and for each diagram we are going to calculate the 1 year forward rate. In other words, when they say 1 year forward rate is a rate that you agree on a year before the application of that rate for discounting or for investment. So in other words, for our 2-year bond, you will in year 1 agree on a forward rate that is going to be used from year 1 to the end of year 2. And then for the 3-year bond, you are going to agree for a forward rate that is going to be used from year 2 to the end of year 3. And the following diagram they are applicable. The following diagrams are actually applicable. So we want to calculate Fn from the yields of zero coupon bonds. So basically, we want to calculate Fn, which is forward rate, and N will tell you the period for which the forward rate is being calculated. And here it's a 1 year forward rate, meaning that we just agree at the beginning of the 1 year that the rate will be applicable. So we want to calculate Fn from the yields of the zero coupon bonds. From the zero coupon yields calculated in the first part. Of the question. So then we can say for the first part, we have the 2-year bond, 0, 1, 2, and we know from the information that we have been given that the rate for 1 year, for a 1 year zero coupon bond is 4.5%. So the rate here is 4.5%. And we need to find the rate that will prevail there, but we have to agree here. So this is F2, that is the future or the forward rate that is going to be used for this period. But we already know from our calculation here that the spot rate for the 2-year period is 5.320 to 43628. So that is the scenario that we have for the first part to the second question. Then the third scenario is we have the 3-year bond. So we have our first year there, our second year there. So this is 0, this is 1, this is 2, and this is 3. So we know that the first period spot rate is 4.5%. And here, let me use a different color so you can appreciate the difference. And then we know that this is the second period, the 2-year spot rate, which is 5.320 to 43628. And we have also calculated Y3, which is the third period spot rate. So here we have the following spot rate. This is 5.6324.172%, and here we have to put the percent sign to indicate that we are already in the percentages. When we do our calculations, we'll use the depth maps. So this one will be 5.3%. So what we are now doing is, for this part, we lock in a forward rate that is going to apply between 2 and 3, and we agree to that rate at 2. So we put here F3. So this is 1 year and this is 1 year, which is the reason why they are saying 1 year forward rates. So there are 2 that we need to calculate, F2 and F3. And here is the reasoning behind the calculation. You imagine that we have got an investment that is going to start to apply F2 when it gets to period 1. So you can use that investment starting from 0, and then it applies 4.5% to period 1, and then it applies F2 to period 2. Or you can just say, we are starting with this investment from here, and at this point we apply the 2-year period spot rate. So then what this means, we have 2 strategies, and using those 2 strategies, our return should be the same. If our return differs, then there will be an arbitrage opportunity. So we have 1.045 multiplied by 1 plus F2 equals to 1.05320243628 squared, because this is going to be applied over 2 periods. So whatever your nominal is, you can use. If you use 1, we start with the $1 there, and we use this strategy to get it to the future value there. That future value is the same as getting the $1 and keeping it until period 2 using this spot rate. So at the end of the day, your future value for the 2 strategies should be exactly the same. So then what this means is we will have here 1 plus F2 equals to 1.05320243628 squared divided by 1.045, and therefore F2 equals to 1.05, 1.05320243628 squared all over 1.045 minus 1. That one comes that side, and it subtracts. And you can work out this with your calculator. You will find out that F2 is equal to 0.06146 9225. And so the 1-year forward rate F2 is equal to 6.14692225%, and you can write this 2 decimals, which will give you 6.15%, and this part is done. Then this is your first scenario, and this is your second scenario. So for the second scenario, we can put a dotted line there, just to indicate that we are now doing the other side of the question. So in the second scenario, the same reasoning applies. We have a strategy, two strategies which we can apply, and if you apply them correctly, they should give you the same future value. So you can start with your investment at 0, apply the 2-year spot rate until year 2, and at year 2 you agree to a forward rate that you will use until year 3, and the future value of this investment should be the same as holding the same investment throughout the whole period and applying the spot rate for the whole period. So this becomes $1.53202436228 squared 1 plus F3, and you can notice that we have squared this because it is a 2-year, 2-period spot rate, and this one is 1, which is in answering the 1-year forward rate, and this is equal to the same investment using the 3-period spot rate or zero coupon yield equivalence. So this would be 1.056324172 to the power 3, because this is a 3-period that we are looking at. So we bring this side to divide, and here we have 1 plus F3, which is equal to 1.056324172 to the power 3, all divided by 1. This should be 0.5, not 1.5. 0.5, because it's 5%. So those are some of the silly mistakes that can happen in an exam. You will watch fat fingers. Even in the banking industry it happens. Where you are supposed to pay $1 million, you pay billions. So here it's 1.053202436628 squared, and then you say F3 is equal to 1.056324172 to the power 3 divided by 1.05320243628 to the power 2 minus 1. Then it is a trivial issue for you to calculate this, and you will find out that your F3 is actually equal to 0.062595429 973 and the 1 year forward rate equals to 6.259542973%, and you can actually round this off to 0.26%. So this question is done. It was quite an interesting question. I'm going to put it on Udemy as well as on YouTube. Please watch and like our videos and subscribe and share with your friends, discuss, and you can send me more questions on my WhatsApp platform using 081 4411 390. 081 4411 390. Thank you. Just as an addendum to the solution to this question, you can see in our computation for F2 and F3 that there is a pattern, and the pattern that we see here actually leads to a formula for the calculation of the 1 year forward rate. So if you want to calculate Fn, we say Fn equals to 1 plus yield to maturity for n to the power n over 1 plus yield to maturity for n minus 1 to the power n minus 1, and then we subtract 1. This formula will give you exactly the same answers as we did, as long as you are putting in the correct variables there. And what we are saying yield to maturity n, we are actually just saying the spot rate at period n. So here your spot rate for 2 would be that one, and your spot rate for n minus 1 would be the 4.5. And that concludes the solution. I thank you.